You all are good and doing well for the preparation of your exam, CA exam. Guys, today I have solved the paper which you have attempted for May June 2025. Course variant is 9709/12. So here is solved for you for the questions starting from 1. This is the title page of the exam paper. It's 2025, May June 2025. The first question. The diagram shows the graph of the equation y equal to f of x and y equal to g of x. Describe fully a sequence of two transformations which transform the graph of y equal to f of x to the graph of y equal to g of x. Make clear the order in which the transformation should be applied. Very much clear. Actually, the question here starting from here, if you go with this, so this is a figure, and the red portion I have marked for you just for sake of some information. Okay. Actual question is this. You got the question. So first we can see the figure shows a stretch from f of x, like from here to here. That is stretch of the along y-axis, because from 6 to, you can see, is 2, or and this has been done with the stretch along the y-axis with stretch factor of 2. How comes 2? You can see if this 1 point and 1 2 point is here, or 1 2 3 point here, so 1 2 3 4 5 6 point, the scale factor seem to be 2, and then it has been translated in the negative y-axis downward with the translation vector of 0 and minus 14. You can see it. And similarly, we go for the question number 2. Find the coordinate of the points of intersection of the curve and the line with equations. A curve has equation 2xy plus 5y squared equal to 24, while the line has 2x plus y plus 4 equal to 0. It's a very simple case, just for the case of simultaneous solutions of the two, curve and line. So we did it. First we make the subject x, or you can make y. I made it x because x will be substituted only once in the curve. So I make x as a subject and replace it in the curve to get y, two values of y. By replacing back to the line or anywhere, I got the 2 points where the line and curve intersects. I hope it is clear. It's a simple case. 4 marks question. And similarly, it's from binomial expansion. The coefficient of x7 in the expansion of this one is 1280. Value of p constants is again easy question. We expand till we get x7, and x7, the coefficient of x7 seems to be here, and that is simplified form is this: 10p squared times 4 power 3 over p cube, and that is equal to the number given 1280. So after simplifying, we will get the result p is equal to 1 by 2. Simple case. 4 more marks for this case. Question number 4. A point p is moving along the curve with equation this in such a way that the x coordinates of the point is increasing at a constant rate of 5 units per second. It's a constant rate. Find the rate at which the y coordinates of p is changing when x9 give you answer in term of a. This is a simple case study that you are given the equation of the curve is y equal to ax cube to the power 3 by 2 minus 12x. So, and along with it, we have given the rate of change of x coordinate is 5 units per second. We have to find the rate of change of y coordinates, and for that we need dy by dx at point x equal to 9. So first we define the first derivative of the curve, and we replace x in the answer with 9. We will get dy by dx 9 is like this: 99 minus 9a. This is what? 9a over 2 minus 12 at x equal to 9. Now by applying the chain rule for the rate of change, this is the rule, it will be mentioned in the formula sheet as well. So we replace the values and finally we get dy by dt. We need the y coordinates of P is, that is 45a by 2 minus 60. B part, given that the curve has a minimum point, minimum maximum point, the point where the curve changes shape, that is dy by dx is 0 at that point. So we replace dy by dx as 0, and already in the first part we have done dy by dx is equal to this. So we equate 0 to get the value of a, that is 16. So far the questions seem to be easy. And question 5, the curve has this one, state the greatest and the least possible value of y. We have different options to get it. Either you can do it directly, or this is 2 marks. So the range of the x coordinates are from 0 to 2 pi. We can 0 to 2 pi. You can break that as given in the graph. Even the points are marked. I just took these points in the x coordinate. After replacing that, I get y, that is 7 or minus 7, just tossing in between these. So least value is minus 1 and the greatest value is 7. And same coordinate points I plotted on the graph to get this shape. And a 1 marks question, a C part, hence determine the number of solutions of the equations. The same question, when is equal to 2x minus 1. So we get here with the line we have 3. Once you draw 2x minus 1, so it means so here in part C you can see the same curve has been intersected by 2x minus 1, the line 2x minus 1. So that is drawn by this black portion here, and you can see that crosses the curve at 3 points. So you have 3 solutions of there while solving this curve and the line. I hope it's clear. Next question is from, this is the diagram shows a curve with equation y equal to 9 over x, this 5x plus 4 whole power 1 by 2, and the line y equal to this. The line and the curve intersect at the point P, which has coordinate y coordinate 3. Area of the shaded region, fine. Y coordinate is 3, it means here it is 3. All right, let me, here it is 3, y coordinate is 3. So if you replace y in either line or you can say in the curve, you will get the x coordinate, that is 1. So this is a P coordinates has when x is 1, y is 3. So you can see the x coordinates at x is 1 and 3. So I want to find this coordinate as well. So at x-axis we know at x-axis this point is lying at x-axis, y is 0. So we can see it's 2, 0. So it means this is 2 and 0 point lying on the x-axis. Now we are interested to find the shaded area applying the rule from, if you talk about the curve in this shaded portion. I'm going to highlight this one, this whole shaded portion. This from range from 0 to 1, this is for the curve. From this portion is only for the curve. So I will take the 0 to 1 for the curve here, and then the line from point P onward makes a right angle. This is a, you can see it's a right angle triangle. So half base into height I can apply it. So finally I get the answer after solving this simply 51 over 10 units square. That will be my answer. I hope it's clear. Next one is prove the identity from trigonometry. You know well, taking left hand side after simplifying, tan theta is equal to tan theta is what the ratio of sine theta to cos theta. I simply wrote this tan theta. I broke tan theta into sine over cos theta and took the LCM. And same thing I did with the denominator. Tan square means sine square cos square, and took the LCM. After simplifying and writing the right hand side, that is the proof of the part A. I did it directly. You can do the steps. We can increase 1 or 2 more steps. Next, B part, hence solve the equation. The same part is equal to 5 by 12. So already we got this result in the first part proved. That was the actual question. Tan theta plus 7 over tan square theta minus 3. So I wrote all this value from the question in part A, and that equate to 5 by tan theta. After simplifying, I get a quadratic term in term of tan theta, and solving it, and it is given that the domain of theta is from 0 to 180. So negative sign indicates, here negative sign indicates that it's lying in second or in fourth quadrant. Positive shows it first and third quadrant. So as its range from 0 to 180, so I will cross the third quadrant and the fourth quadrant, because the value will not fall here in any one of these two quadrants. So first quadrant, for when tan theta is equal to 3, I got theta is equal to 71.6. That's one of my answer. Other cases, theta is equal to 51.3 when it is negative. So this is a basic angle, but I'm interested to go with the second quadrant. Second quadrant is less than 180. So 180 minus 51.3, I will get 128. This is my second answer. Similarly, this is very interesting question number 8. And it's little tricky. You need to focus on it little and comprehend it. First part is very much easy. The diagram shows a circle with the equation this one and the line this one. The line intersects the circle at the point A and B and the center of C. Find the coordinate ABC. Just we need to solve the curve and the line simultaneously. Replace y equal to -2. We get the two coordinates of x. That makes it mean y is -2, right? Y is -2 here, but x changes from 2 to 12. So the coordinates of A and B are 2 to 12. It was very much clear that the coordinate of C is the center, is mentioned center of the circle. So it will be by applying the midpoint formula. Either we can solve in the other approaches as well. I did with the midpoint formula. I got the x coordinate is 7, and from till x-axis we have to go jump 2 points. So it means here it's -4. So 7 and -4 is the coordinate of C. B part says find the angle ACB in radian. Give you answer in 3 significant figures. So very much clear. Already we have calculated the coordinates of midpoint, and the midpoint is how much away from the B or A, that is 5. I can apply the length formula, or even from this figure, original figure. M was at 7, and here it is M, right, on x-axis, and B is at 12. So difference is 5 step ahead. So I can get this length is 5. And similarly at from M to C, M to C M is here, M is here, this is 5. So M to C is 2 step down. You can see the difference. So I wrote it here, is 2, MC is 2. So by applying, I am going to find this theta, half of this, because a line from the center to the chord bisects the chord. So I can say by using this property, I can find theta is 1.98, but I'm interested to find ACB, the whole angle, 2 times of theta. That is final 2.38 in radian up to 3 significant figures. C part, the chord AB divides the circle into 2 segments. Area of the larger segment. Okay, that's very much clear. AB divides in 2 segments. Here you can see this line AB divides it into 2 segments, one above, one below. So we have different approaches to solve this question as well, but I tried to solve it with a simple approach. First of all, I got the radius AC or AB same, that is square root of 29. Area of largest sector, I calculated it, that's half r square theta. That comes to 1131 over 20. That's giving me in 2 decimal place 56.655 centimeter. So area of triangle, ACB, triangle ACB, this half AB sine theta. So applied it, that comes to be 10. And now area of larger segment will be triangle area plus area of sector. We'll get the result, that is 66.55. Next question number 9. The equation of the curve is such that second derivative is given to you, and it is given that the curve has a stationary point at -2 to 19. Find an expression dy by dx. From second derivative to first derivative, you know we need to integrate the function. We integrated it and by replacing the constant of integration c. But as the points is given that x is minus 12, y is 19, I replaced, you know, here for value of c. It's a stationary point. Stationary point means dy by dx is 0. I took dy by dx 0 and replacing this point minus 2 to 19, I got c is equal to minus 3. So then finally my result is dy by dx is equal to 12 by x square minus 3. B part of the same question, it's an easy question as well. Find the x coordinate of the other stationary point of the curve. For other stationary point, you know, we need to put dy by dx equal to 0. We replace it and we get x equal to plus minus 2. But as already x was minus 2 here, x was minus 2. So now we will take the other option that x is equal to plus 2. So x plus 2, we put it in the second derivative to get the result that is minus 3, that is less than 0. So it means the nature will be maximum. Nature of the stationary point is maximum. C part, find the equation of the curve. Okay, equation of the curve, we need y in term of x. So we again integrate the first result of dy by dx from here, from part A, and we place the constant integration, and that again the point given to us in the start of the question, that curve at minus 2 and 19. So replacing it, we got x c is equal to 7, and then finally the line is y equal to minus 12x minus 3x plus 7. So 3 marks, easy one. D part, the equation of the normal to the curve at where dy by dx is minus 9 by 4. It means dy by dx minus 9 by 4 means this represents a gradient of the equation of the normal. Equation of curve, equation of curve. For the normal, you need to take negative reciprocal of this gradient to get the gradient of the normal. That will be, any m normal will be 4 by 9, because negative reciprocal of the curve's gradient. So and x is positive is given. It's important point, x is positive. So we calculated it, dy by dx, and we equate the dy by dx equal to minus 9 by 4. It was given to us here. So after solving, we get x equal to plus minus 4, but we took x 4. Reason, it is given x is positive. We will not go with the negative. If the option is negative, then we can switch it for the negative case. So by replacing this x4 in the above part C, this line, we will get y equal to minus 8. So the point equation of the normal at point 4 comma minus 8 with gradient 4 by 9 is, I use this formula, or you can apply y equal to mx plus c. Choice is yours, and final answer will be in term of px plus qy plus r equal to 0. I wrote it here. Question number 10 is from APGP. It's another easy question. The first, second, and third term of arithmetic progression is, first is a, second is a plus d, this is a plus 2d. Respectively, where this constant, find the value of k. We know that for any AP, the d stands for the common difference that will be always same throughout the sequence. So from 1 and 2 we get d in term of k like this, and from 2 3 we get d again in term of k like this. We equate these two differences and we got value of k, that is 6. Find sum to first 20 term of the progression. So we know the formula. It is given the formula as n is equal to n by 2 times a plus n minus 1 times d. It is given in the formula sheet as well. So I replace n20. A is already, we get after replacing k 6 in the equation number 1, we get a this, and in any one of the d we get d is equal to 12. Replacing all these values, n is 20. We can replace in the formula to get answers, as 20 is 2760. That is pretty easy question. B part of the same, that is the fourth and the sixth term of a geometric progression. This time you are encountering the question, instead of AP it is GP, and GP we know that the fourth term is AR cube and sixth term is AR 5. That is given to be us. So common ratio, we divide the first and second term with the first one, we got R is equal to in term of this, because it is given, give you answer in term of like this form. fraction with surds. So a we calculated 216 after simplifying 216 square root 6. So sum to infinity, this is again formula given in the formula sheet. We know that's a over 1 minus r. I just replaced the values and simplified to get my answer, and I compare the results with the required format. A stand for 1296, B stand for 6, and C stand for 1. 5 marks, easiest question. Yeah, and 2 marks bonus question, again computing square method. You need to solve it to get the expression in this form. A and B stands for. And B part, you are given two function f and g in this here. F is the same like we did in part A, that is, in the completing square. We can write it and we need to find inverse of it. So we know whenever we have a quadratic equation in a function and we have to find the inverse, we always make the completing square format. So, and domain is x is less than or equal to minus 2. Keep this in mind. It's a very important point for here for the selection of final result. So we make the x as subject, taking square root on either side. Y goes here, x goes here, and we have plus minus. Then finally I will replace x is equal to minus 2. Instead of writing plus or minus, I will select minus because x is less than minus 2. So I will take square root term as a negative. So f inverse will be minus 2 minus this, and after replacing x and y we get this result. This is an f inverse of x. And for part 2, g f inverse of x, we have two approaches. G f whole inverse of x, that stand for f inverse times g inverse. Either this or this. I just first find it a composite function f in g, and that I get this one, and then I wrote it in completing square to get f in g as like this. So now I select this g f as a y and make x as a subject again. So again the conditions of domain for the given is, we will go with the f function that is going to be inserted in g. So f for f of x, we are given x is less than or equal to minus 2. So I will select the negative sign up again here to get my answer. This is the final format of the paper. I hope you got it, and wish you good luck and keep watching the rest of my videos.